We're going to be talking about when to use standard access lists, the number range that I mentioned in the previous videos, the commands to configure the standard access list as well as apply it to the interface, how we can use an access list to specify who can telnet into our router, not passing through our router but telnet actually to the router. We can control that virtual terminal line with an access list and who can telnet in, as well as troubleshooting access lists. I've brought up some configuration examples so we can take a look at how we configure this standard access list. Now it's important to remember that we use a standard access list when we want to block all traffic or permit all traffic from a particular source or destination. Let's take a look at this machine right here. 172.16.3.20 is his IP address. Let's say we want to stop him from going into the Ethernet interface. I'm the admin, he made me mad, so I'm going to block all his traffic. He can't get out anymore. Maybe this is even the internet out here. And we know people like their internet access, so to get back at him, I'm going to block it. What I can do is, I can use a deny statement in my access list. Access list 1, deny, and then I have a couple of different options. I can either use host, the word host, type access list 1 deny host and then his IP address, or I can go access list 1 deny his IP address and then an all 0 wildcard mask. Let's take a look at that. I'm bringing up an actual router here and we'll take a look at configuring that. Access list, and then I have to specify, and look at all the different access lists out there. IP extended access list, standard 48-bit MAC address access lists, protocol type codes, IPs, and there's actually a bunch more that aren't even on here. This router is a little bit older. We don't have the extended access list range. They have access lists for IPX traffic. I mean, Apple Talk, just about anything you want, there's an access list number range for it. Now, so I go access list 1, and I'm blocking that host. So I'm typing deny, not permit. So I'm blocking that host. Now there's a couple of different things I can do. I can type the word host. Host 172.16.3.20. I think that was his IP address, 3.20. So I can do that and hit enter, and I've created the access list at that point. That's a one statement access list. Or I could use access list 1 deny, and I could type in 172.16.3.20 0.0.0.0 all 0 wildcard mask. And again, this means 0 must be 172, 0 must be 16, 0 must be 3, 0 must be a 20, so it's only going to match that host. These two statements are exactly the same, other than the fact I use host here instead of an all 0 wildcard mask there. Technically, they accomplish exactly the same thing. So, once I've created the access list, I can go in and view it. Show run. And I can see my access list. And there's a problem with this particular access list, and I'll talk about that in a second. If I go back over here, we've created the access list, but we haven't applied it to anything. Remember, we want to apply it to Ethernet 0 on the way in. It doesn't do me any good to create an access list and not give it to an interface. I can apply the same access list to different interfaces in different directions. I can put one access list on the way in Ethernet 0 and on the way out. Doesn't always make sense to do that, but I could if I wanted to. That might make me feel better. IP access group command is what we use to specify the access list and apply it to the interface. There's a big difference here. When we're applying the access list to the interface, we actually type IP first. When we create the access list, we do not type IP. The reason I'm stressing this is because there's what's called a named access list that we will be going over with the extended access lists in another video. If we were to type IP first, what would happen is it would go in and start creating a named access list, and it follows a different pattern. We still accomplish the same thing, but we're doing it a little bit differently, and I want to show you how to do that. Do not confuse the two. We don't need to type IP when we're creating the access list. And as I said earlier, that's because the number 1 here tells the router that it is an IP access list and it is standard. So meaning it's going to look at the source address for IP traffic. The one already says IP, so we don't need to specify IP when we create it. When we apply it to the interface, however, we do. So let's take a look at applying it to the Ethernet interface on the way in. Go into global mode, interface Ethernet 0, IP access. I always hit tab there so I can complete it out because I don't have to type the whole thing. IP access group 1 and in or out. Now we're looking at this. It's entering into the router here before the routing decision right here. So we're going to go ahead and specify on the way in. Now we've created an access list and we have applied it to an interface. If I do a show run, I can look under my Ethernet 0 interface and I see an access list has been applied and the access list has been created down here. There is a problem with this access list though. If there were other machines, which there usually are, more than one unless you're just a very small home network, all these guys are not going to be very happy. They've got their angry faces on right now. They're not going to be happy because you messed up the access list. Or I should say, I messed up the access list. We did not put a permit statement in there. At the end of every access list is an implicit deny all traffic or any traffic. Meaning, if the access list doesn't say to permit the other traffic, it's going to block it. So we have to have this permit statement at the bottom of the access list. Access list 1 permit, and then we can either use the word any or 0000255255255255. Either way we want to do it, but we've got to add that in there. So to put the permit statement in there, I just go back to global mode and I just start typing access list, and I use the same number because it's a part of the same access list. I can have as many entries as I want to in this access list. Permit, and I'll just use the word any because it's easier to type than 0000255255255255. Now if I do a show access lists, if I take a look at this, I can see that I have a deny statement of 172.16.320. I'm blocking that host, and I'm permitting all other traffic. I can also look at it through show run, which is short for show running config, and I can see that I'm blocking that IP and permitting everything else. The order of these is very important. If the order were reversed, meaning the permit statement on top of the deny statement, what would happen is, if we're looking back at our slide, when this machine were to go through, the router would check the traffic against the access list, and the access list here, if this statement was first, the permit statement, access list 1 permit any, allowing all the traffic to go through. If he hit that statement, that's the first statement listed, it's going to go, oh, you're part of any traffic, go ahead and go. It will never make it to the next statement. It won't make it to the deny statement. As soon as it sees a statement that it matches, it goes ahead and does that action. It doesn't keep processing down the list. That's why it's important to put the more specific entries first in the access list, like the deny this particular IP. Because what will happen when these guys go out, if they want to go out, we're taking a look at our access list, and this guy might have an IP address of 3.30. If we're looking at the access list, he'll go through and the router will check. It'll go, okay, your source address is 172.16.3.30. That does not match because there's a 20 here in the deny statement. So that doesn't match you. Let's check the next statement. Access list 1 permit any. Oh, that does match you because you're a part of everything else. You can go ahead and go. If this statement would go, we're not there, he'd check and be like, okay, that's not you, so I'm not going to deny you, but it doesn't tell me to let you go through either, so I'm going to go ahead and block you for safety purposes. Let's take a look at a couple of other scenarios. Here's a diagram that I just threw all kinds of stuff in just for practice purposes. And let's say this subnet right here is sectioned off from the rest of the network because that's the accounting department. And there is a company auditor, maybe this machine right here is the auditor in the company, and they need to be able to have access to this server, the accounting server, the client machines over here, whatever. For whatever purpose, we want to allow this auditor to go into this network, but not these guys. We don't want the other machines to get through there. So what we could do is we could put one permit statement on the way in here. So let's say this is Ethernet 1 interface, this is Ethernet 0 interface. What I could do is I could put the access list on either one of these interfaces, really. In this situation, even though Cisco says recommended to put as close to the destination as possible, since there aren't any other interfaces on this router, I would put the access list on Ethernet 1 on the way in. What I could do is I could just permit the auditor's IP address. Maybe this subnet right here, or his IP, the subnet is 172.16.10.0, and the auditor's IP is .22. So I'm going to create an access list to just allow the auditor through and block everything else. I don't want anyone else going there. Now, what that will do, if I just permit the auditor and don't allow any other traffic, that means that these machines here can't go to the outside world. Maybe they don't need to, whatever the case, but if I were to block traffic and just allow the auditor in here with standard access lists, that means these guys could send out and maybe even go, if this is the internet, here's an ISP, the WAN cloud, whatever, the traffic from the internet would not be able to go back through because I'm only allowing the auditor's machine to go in. So those guys could get out, but any internet traffic, anything like that, not going to be able to get back through. Usually that's a good thing. That way these guys will be doing their number crunching instead of surfing the net and bringing viruses onto our network. So let me go in and create an access list to just allow the auditor through this interface. Bring up the hyperterminal here, go into global mode, access list, and we'll create a number between 1 and 99. I'll just use 1, permit, and then I specify the IP address. Remember, I can do host, and then the IP, 172.16.10.22, enter, or I could do the IP and then all zeros wildcard mask. And then I simply go to the interface. Interface, this does not have an Ethernet 1 interface, so we're going to pretend that this says Ethernet 1. And I use the IP access group 1 in. Again, pretending that that's Ethernet 1 interface. What we've done is we've just created an access list permitting only this machine and applied it to the Ethernet 1 interface on the way in. Now, notice I just put one permit statement on that access list. And the reason I only have one permit statement is because I don't want to allow any other traffic into that subnet. So if taking a look at this access list, let me get rid of this other statement. If looking at that, let's pretend this other statement's here. Looking at this right here, access list 1 permit, just with that permit statement, nothing else, it would block everything out. Let me fix that. If I want to get rid of this stuff, watch what happens if I go no, and I'll just try to remove this one line right here. Let me paste that in there. I'm just trying to remove that one line. Watch what happens when I do show access lists. Show, let me fix this so you can see it. Access lists. Nothing. If I do a show run, it's all gone. You cannot remove an individual statement from a regular, standard, or extended access list. I might as well have just typed no access list 1, and that gets rid of the whole list. I can't just remove an individual statement. That's why access lists are recommended to be created in Notepad. I can create the access list in Notepad and save it. Just like I'm typing, I can actually create a whole router configuration in Notepad. I'll go access list 1, permit 172.16.3. Or that was 10.22. And use my wildcard mask of all zeros to match that particular host. And I might want to put a few more. I might want to permit a few other machines. Maybe I have admin machines or things like that, and I want to put a few more in there. So I'm going to go in and create this in my Notepad, and maybe I also want to allow machine 44, machine 53. So I want to allow those 3 machines and no other machines to go through that interface. Check this out. All I have to do is save this access list. I'll save it so I can edit it later on. I just right click, highlight it, copy, go back to my prompt, get into global mode, right click here, paste to host. Control V doesn't work very well through the hyperterminal. Show run, and check it out. Access list 1 permit those 3 machines. Since there's an implicit deny all at the end, everything else will be blocked. And notice it's still applied to Ethernet 0 on the way in. Just because I removed the access list does not remove the access list access group command at the interface. So if I were cleaning it up, I'd have to go to the interface and remove this command as well. What I see a lot of people do when they try to remove the access list from the interface, they just go IP access group 1 enter. They forget the enter out. So if you're removing things, a lot of times it's helpful just to right click, highlight it, go copy interface Ethernet 0, type no, and then paste the whole line. That way we eliminate some of that user error and remove that access list off of the interface. So it's gone. So the access list is still there, but it's not applied to any interface, so it has no effect on the machine whatsoever. And what's nice about having it all in Notepad, maybe I made a mistake. Oops, I didn't mean 53. I meant 35. And I don't want 22 anymore. I want 19. Something like that. Maybe I wanted to make some changes. All I have to do is go in and edit it in Notepad, save it, make a copy of it, go back here, get rid of the access list, no access list 1, enter, and if we do a show access list, it's gone. Let me go back so we can see that. Show access list, there's no access list anymore. So one line gets rid of it. So I edit, there might be 50 statements in my access list, and all I have to do is go no access list 1, make my changes, copy the new access list or the changed access list out of Notepad. Whoops, I meant to paste it to the host. Let me try that again. Copy out of Notepad, paste it back into the host. Okay, let me make sure it says paste here, not copy again. I paste it back in, and I like show run to look at everything, so I'm just going to do show run. And I can see my access list there with the new changes. So even though there might be 50, 60 lines in an access list, I've seen some really long ones, it's not a big deal to go in and edit it. I don't have to go in and type all 60 lines over if I've done it in Notepad. Maybe I didn't do it in Notepad. What a bummer, and I want to make some changes. All I have to do is copy it out of Notepad first, copy, paste into Notepad, go ahead and make some changes. Oh, that's 55, that's, I don't know, 9, and I'll leave that at 19. And I just copy right out of the show run and paste it back in. Paste it in a Notepad. make my changes. No access list 1. And then paste my new access list back in. So it's real helpful to work with Notepad when you're creating these access lists. I brought up my scenario diagram again, and we're going to look at one more thing. As I said earlier, this might be the accounting subnet here, or I'll just say it's the accounting subnet. So it is. And I don't want these guys getting out. So what I can do is maybe I want them to be able to go out and talk to these computers, the ones that I have access to, because I remember I wanted .22 to be able to go in and talk to these guys. So I don't want to block any of these machines at this interface or this interface, because then the information wouldn't be able to go back out to the 22 machine. But I don't want the accounting server or the accounting employee going to the net. So at Ethernet 0, even though technically internet traffic can't go back in because I'm only allowing 22 to these machines, I don't want them sending anything out either in the first place. I don't want any packet going out. So what I'll do is on Ethernet 0, I'll block this subnet from going in to Ethernet 0 on this router right here. Maybe this is router A, whatever. So what I'm going to do is I'm going to create an access list to block this traffic from going into Ethernet 0, but allow all the other traffic to go out. And maybe there's more subnets over here. There might be some other routers over here with some more subnets. So I'm just going to block these guys and permit everything else. Let me go to my router and do that. So I go into global mode and I'll create an access list. Let me get rid of access list 1. No access list 1. And I just create a new access list. Access list, I don't know, 20. And I'm denying 172.16.11.0. And remember, since I'm blocking this entire subnet, the wildcard mask is 0.0.0.255. So I'm blocking that. I'm permitting everything else. So access list 20, permit any other traffic. I'm done, and then I go to the interface Ethernet 0, IP access group, and that's access list 20. So access list 20 I'm applying. I'm grouping access list 20 to the interface on the way in. If I do a show run, I can take a look at the interface, and I can see that access list 20 is applied on the way in, and then access list 20 is denying subnet 11. So anything 172.16 and 11 in the first 3 octets, doesn't matter what's in the last octet, is going to get blocked. Everything else is permitted. So what effect that will have with that access list applied right here is 10 can get out. Any other subnets, maybe you got 12, 13, whatever subnets over here, they can go through and get out. But this subnet, they can communicate into here, but they won't be able to get through this Ethernet 0 interface on the way into the router. What I want to do now is take a look at Telnet control, and not Telnet passing through the router, but Telnet to the router itself. Let me clean up this slide and explain what I mean. So here's a situation for controlling Telnet traffic into the router. Let's say the router has a public IP address on this interface. Here's a service provider, actual internet going on here, and this IP address is 121.10, that's not a 6, .33.4. And the admin here has an IP address, public IP 99.8.64.3. And I want to allow this guy to be able to telnet in, but I don't want anyone else to telnet in. Maybe from the backside they're using the 172.16 network back here, and it's subnetted out, but it's still all the 172.16 network, so I want to allow telnet from the inside to the router and telnet from this one public IP address into the router. Now I don't have to create access lists and apply them to the interfaces here. We do that for traffic passing through the router, like maybe allowing this guy to telnet to this server back here. We'd allow traffic to pass through the routers to this server. But we're controlling telnet traffic to the router, so this guy can remote in and check out the router if there's any problems. So what I do is I'm going to go in and create a standard access list. We use a standard access list and apply it to the VTY lines on this router. So let's go to the router and configure this access list. So I'm going to create this in Notepad. And I use a standard access list. So I go access list, I don't know, we'll use 11. We're permitting that public IP address of 99.8.64.3. So we're going to go host 99.8.64.3. Access list 11, because we're also going to permit the internal network, which is 172.16.0.0, and to allow the entire network 0.0.255.255. That means 172 and 16 in the first 2 octets. I mean, I don't care what's in the last 2 octets as long as it's 172, 16 in the first 2. That's all we have to do for that access list. Remember that there's an implicit deny all at the end of every access list, so that's all we have to do. So I'm going to copy this and paste it into the router. So we go into global mode, into global mode, and I paste my access list and create it, and now I have to apply it. Now I'm going to check out the running configuration to see where I apply this thing. Telnet line VTY space 0 space 4, that's the 5 telnet sessions I can have on this router, so that's where I want to apply that access list to the actual virtual lines that dead end at the router. It's not at an interface, it's actually at the virtual interfaces. And to do that, I use a different command. I go to line. It actually tells me exactly what I need to do right here. Maybe I better copy and paste that instead of typing it out. Maybe I won't get it right. So paste the host, line VTY04. And the command is access class. Then the access list number 11 in. Control Z, show run. So by applying it to the actual telnet lines, access list 11, you can see right here, is applied to line VTY space 0 space 4 on the way in. So it's only permitting 99.8.64.3 and anything from the 172.16 network. What that accomplishes is anyone out here can telnet in. And again, I'd have passwords and things like that, that only the admin would know. So some guy over here can't try to telnet into the router and get in. Or this public IP, that's the admin's public IP, can telnet into the router and access the virtual terminal lines to be able to configure the router. So that's applying an access list to the virtual terminal lines and controlling telnet. I brought up the slide that had the commands on it again, and for a standard access list, it's just access list 1, permit or deny, and then you can use host if you want to, and then the source address. You can also, for the permit statement, general permit statement, all other traffic, you can use the word any or a bunch of zeros and a bunch of 255s. I like any because it's only 3 characters versus a bunch. IP access group is what applies the access list to an interface, like Ethernet or serial interface. If I'm going to apply the access list to Telnet line, the virtual terminal lines, I use the access class command. That's pretty much always going to be on the way in. So let's go quick recap on what we've covered thus far. So at this point, we've covered all the configuration aspects. We're going to have to go in and do some troubleshooting here. We talked about when to use it, the number range, commands, as well as the application on the Telnet interface. So let's go in and look at how we troubleshoot these access lists. Let me bring up the router interface. First things I'm going to check when I'm troubleshooting the access list is I'm going to do a show run, and I'm going to look very carefully at the access list. It is extremely important to verify the IP addresses. You want to check that out. Permit 99.8.64.3. Permit 172.16.00, 00255.255. Verify the IPs, especially when you're talking about a host IP. One little thing can be off. I always read them out loud to myself. If I'm just looking at it, glancing, it's easy for my mind to fill in the appropriate number. Maybe that's not supposed to be an 8. Maybe that's supposed to be a 9 or something like that. People tend to look at the last octet. You need to verify every octet, and I read it out loud. 99.8.64.3. Very important. I check my permit statements. My application statements like access class or IP access group. If somebody's trying to get in, like maybe I'm allowing this machine right here into this subnet, this is the accounting subnet back here, I want to make sure that the access list is applied to the appropriate interface. Is it in the appropriate direction on the way in and not on the way out? Very important to look at the direction of the access lists, make sure it's appropriate. Also, let's say this machine can't get through for whatever reason. I'm trying to get to the server to check it out as the auditor, but I can't. Try removing the access list from the interface. So if this is the Ethernet 0 interface right here, I'll go in and remove the access list from the interface as a test to see if they can get in at that point. So I'll go into interface Ethernet 0, no IP access group, and let's just say it's access list, 10. In. I'll remove it. I won't get rid of the access list, I'll just remove it from the interface, and then I'll go back and try to access it from this machine. So if you have to, get rid of some stuff. Don't get rid of the access list, but remove it. If I remove the access list and then the machine's able to get through, I know the access list is causing the problem. And just because you can't get through doesn't mean there's not a problem with the IPs or at the switch port. Make sure there's general connectivity. I'd try pinging some other machines. Ping this gateway right here. So verify that all the IP stuff is right, then go in and look at the access list. And again, the best troubleshooting for the access list is simply the show run and go in and check out those access lists and where they're applied very carefully. Look at direction, look at the IPs specified, make sure the wildcard mask is appropriate. Verify very carefully that it is correct. Any one of those little things not set right can cause problems. So we have talked about troubleshooting now. So we've covered when to use it, the number ranges, commands, application on the interface, as well as troubleshooting.